Hi everyone, my name is Tessa, and today we're going to be talking about nextTick and the event loop. So, does anyone here read music? Do you know how this beat sounds? And do you know what this rhythm is an example of? Yes, it's a kind of syncopation. Thank you. Wow, I'm so happy. But what is syncopation for the rest of the audience? So, Miles Hoffman, a music commentator at NPR, describes it as a disturbance or interruption of the regular flow of rhythm. But what does that even mean? So, let's go back to our music example. If I show you the lyrics, does it become a more familiar rhythm? So here's the thing. Syncopation can be pretty tricky. Maybe not for all of us, but if you don't know the ins and outs, you might be able to feel how it works, but you don't necessarily understand it. And I've been reading sheet music since first grade, and I'm not the best music reader, but that's a pretty long time. That's way, way longer than I've been coding. And I still find some rhythms tricky to read, and I have to break them down into smaller pieces to understand them. And then sometimes, if I think about it too hard, then the understanding starts to break down again. Similarly, this is an example of some code that I showed last year. I think it's really hard to understand what's going on here. I don't know about the rest of you, but I find that the developer intention is maybe not the clearest here. And I believe that nextTick, like syncopation, is another one of those things that disrupts the regular flow. And if you're anything like me, then you might have some kind of intuition about how or when you might use nextTick without really understanding why, especially if, like me, you have trash brain, but we'll come back to that later. So, we've established that music and coding are very similar in that they're both extremely confusing. And it can be tough to imagine or picture how all of the different parts, whether it's different instruments in an orchestra or different modules in your app, come together, right? And that doesn't even take into account the fact that you can't depend on code or music to run top to bottom, left to right in some kind of predictable order. Can you tell, looking at this code, what order it will run in? Yeah, someone said eventually, so hopefully eventually. But honestly, I have no idea. Hopefully after this talk, it will be a little bit more clear. So time travel, coding, music, these are all already really challenging, right? We've established that they're challenging because they don't necessarily run in order and because there's a lot of different moving pieces and you're not necessarily responsible for all of them. And that's before we even get into the challenge of avoiding tripping over your past self, right? We've all looked at code and been like, who wrote this? And then done git blame and been like, oh, it me. So that can be another huge challenge with coding. Yeah. This is painful. So let's rewind a bit and start off in a more simple place. So if you're unfamiliar, Back to the Future is a movie that stars these two protagonists, the high schooler Marty McFly, and then his friend, the scientist, Dr. Emmett Brown. And they travel through the ages using this magical DeLorean that when it hits 88 miles per hour has the ability to travel through space. And today we're going to recreate their first experiment, sending the Doc's dog, Einstein, 1 minute into the future. So the DeLorean comes with this 3-tier UI, and we use this to travel through time. The first clock is set to the destination that we went to travel to, so in this case, that's going to be 1 minute into the future. The third clock is set to the time when the DeLorean leaves the present to go to some other time. And then the present clock, once you've traveled to the future, it's going to show you what time it is wherever you've landed. So for example, in this experiment, ideally, if I set this time to 22, then this time, if we left at, let's say I set this to 30, actually. Then if we left at 22, this would be set to 22, and this should be set to 30. Does that make sense? Sort of? All right, let's dive into the code. So here I have a template that represents the 3 tiers of the UI and this 88 miles per hour button, and that's what's going to push Ein into the future. And in the DeLorean component, I have this set destination time method, which optionally takes an hour and minute and sets the hour and minute in the destination clock to that past-in time, or by default sets it to just 1 minute into the future, and we're going to be using just that default today. Then in this travel method, I have this function that sets the last departed time to the currently present time, right? We need to set that before we change the present time so that we get what the time was when Aini left the present. Finally, the present time needs to recalibrate once we've traveled to the future to match the destination's hour and minute, and we're going to get that directly off the DOM using refs. So we're not going to be accessing the data in the component, but reading the DOM. And since this talk is ostensibly about nextTick, let's use that to travel to the future for the first time. So who here has used nextTick in tests? I see some hands. It's pretty bright, but I can see. So if you've used it in tests, you probably think of it as the function that you use to wait until something is visible, right? What do the docs have to say about it? It says that nextTick defers the callback to be executed after the next DOM update cycle. Use it immediately after you've changed some data to wait for the DOM update. That's like what I said, right? So if we call $nextTick twice, once with the set destination time and once with the travel method, then I predict that we should see the destination time update first, and then the last departed and present time should update next. Are you all ready to say goodbye to this little dude? Okay, but hang on, there's just one more thing. Since this is an experiment, we should probably equip Aini with a stopwatch that's synchronized to our own so we can make sure that he actually traveled to the future. All right, ready for real? Everybody say bye, Aini. Here we go. Okay, so if everything worked as I expected, then we should see the future and past clocks change and the present clock change, but the future clock first and then the past and present together. But it didn't work. I mean, it kind of did, but the present time is definitely wrong, I think. Probably.
Einstein's clock is exactly 1 minute behind mine and still ticking.
Okay, so maybe it's right in some sense. Like, I don't think off by 1 is too bad of an error to have. It's a classic for a reason, you know? But let's think about this as like business-minded, like product-friendly engineers and look at it from the user's perspective.
He's completely unaware that anything happened. As far as he's concerned, the trip was instantaneous.
So that is the experience that I want to recreate. I want us to look at the clocks from Einstein's perspective. So the present clock really needs to recalibrate to match the destination time rather than matching an old time. Maybe the problem is that the nextTicks were happening at basically the same time. So if I use promises to force them to run one after the other, because if you pass in a callback to $nextTick, then it doesn't return a promise anymore. So here I'm forcing it to permissify. Then maybe we'll get the order that we expect. No! Okay, so now the present is technically the right time, but it looks like it's updating at the same time as the destination time, and that's not what I want. But if I nest it, that feels like that could get around that, right? Is it possible that they're just updating at the same time? I don't know. Okay, so just because nextTick is after a render doesn't mean that it's necessarily right before the next render, right? Even though those kind of feel similar. But I know that if I use request animation frame, that runs definitely before a render, so maybe I can use that to force it to happen. So I feel like this is the one. If I use request animation frame here, that'll like force it to update a second time. Is it possible that it's just like too fast and I'm not seeing the changes in time? So I can check this by turning on paint flashing in the rendering tab of the dev tools. And it looks like there is only one render, which is pretty frustrating because I definitely want to have two separate steps here. So now things are getting kind of gross, but I'm also getting kind of desperate. So let's see if set immediate works. And in this case, I use set immediate just because like I did so much typing at this point, I don't want to bother to put a 0 after set timeout, but you can consider them like the same thing in this example. And it works! we got 2 separate renders, which is great. And of course, nested request animation frame also works, but not if you permissify it. So what is happening here? Is anybody else as confused as I am? Please say yes. Thank you. So in the event loop, I want you to imagine that we have 3 basic types of queues. The first one is the task queue. So this is probably the one that you're most familiar with. It's the one that Philip Roberts talked about in his famous event loop talks, et cetera, et cetera. But today we're going to be focusing on 2 other queues, the flush queue and the microtask queue. So to better understand them, we need to revisit our protagonists, Marty and Doc. And as the main characters of the movie, they have a lot of tasks that they had to complete to drive the story forward to the conclusion. But our audience also has a limited attention span, so they tried to limit each goal that they had to complete to 1 per scene or set. Let's throttle it to that. And sometimes one of them has to split off from the main storyline and take care of their own side mission. But in the end, they always come back together and rejoin and then help move that main storyline forward again. Now, Marty and Doc are the protagonists, but we also have a lot of extras in the movie, and they have their own lives and their own little things that they have to take care of in each scene. Sometimes they move at their own pace in individual cars, and sometimes they all move together in buses. So we can think of Marty and Doc as the task queue, the cars as the microtask queue, and the buses as the flush queue. Now, imagine that you decide to go toe-to-toe against the car. Who's going to win in a fight between you and the car if you're Marty? Yeah, the car. Please don't fight with cars. You will not survive. Or maybe you will, but it's not going to be a fun time for anybody. But the extras driving the cars, so since I'm from New York, when I'm talking about transportation here, I want you to imagine that these are New York drivers and New York buses. And if you know anything about New York drivers and New York buses, anytime they see an opportunity to go, they just go. And Marty and Doc are not from the city, so they probably don't have that kind of mentality. So this means basically anytime Marty or the Doc are not in the middle of doing something, then the car is just going to take its chance and start driving. And similarly, when our tasks finish, that's when our micro-tasks start running. Just like Marty shouldn't get in the way of a car, once our micro-task queue starts flushing, he can't do anything until that's done. Now, buses or flush queues are a little bit different from cars. Marty still can't get in the way of a bus, but buses run on a schedule. And as long as you make the bus in time, you're going along with everybody else. And in the event loop world, that schedule is comprised of something called a tick. Ticks, I find, are a little confusing because with a clock hand, each tick moves it forward only a little piece of the whole cycle. But in an event loop, not only does each tick comprise the entire loop, but it doesn't have a predetermined length. But one thing that we do know is just like Marty and Doc can only complete 1 task per scene, every tick has only 1 task in it. So hopefully that is a little bit helpful. Another way that I thought about it that helps me remember it a little bit better is if I thought of the second hands as our extras. So it can complete many tasks within 1 cycle, but then once it's done, we only have the minute hand move forward once to move forward 1 tick. So in the case of this experiment, Ian can instantly jump to the future in nextTick, but Marty and Doc have to wait until he's traveled before they can meet him in the future. So in terms of view, $nextTick is a function that calls nextTick and passes in the current context, which is going to be the component. So it's basically a way that developers can call nextTick from within a component. And the nextTick component itself, the nextTick function itself is a little bit more complicated. And ironically, even though this talk is about nextTick, we don't need to worry about this right now. Just know that it works. And the reason that I've been calling that third queue the flush queue is because of this flush scheduler queue method. Now this is the one that goes through all of our nextTick callbacks and runs them. And that gets called by this VUeWatcher function. Every component has one. And basically, whenever you change any data in your component that's on the DOM, that's when the VUeWatcher gets triggered. So if I just change data that's not in my template, then this won't get triggered. And then my flush scheduler queue won't run. So now that we know that, let's go back to the code from earlier And before we do, I want to introduce some shorthand that I'm going to be using in the code visualization. So here on the left, I have 3 examples of what the different queues are going to look like. And then on the right, I have these methods. So the first one is push. That's just pushing a function into a queue. And then function parens is the normal invocation syntax. R is what I'm calling the nextTick method here because it calls the render, so we can just think of it as render. And dollar is what I'm using for $nextTick. RAF is request animation frame, capital P is promise, and .then is .then. Another important thing to note here is I'm going to say things like we're calling nextTick, we're calling $nextTick, we're calling request animation frame. And what I mean is that we're calling the callbacks that are passed to those functions, but that's like a lot to say over and over again. Okay, so let's go back to this example where the present time updated to 1 minute too slow. We're going to start by calling our 2 tasks. And those push 2 nextTicks into our flush queue. Since this .travel, sorry, that should be this .set destination time. I changed the method names. Since this .set destination time updates data on the DOM, it's going to, when we run the $nextTick, push a render function into the flush queue. And then that's going to open a new flush queue and then push it in there. So then we call nextTick on set present time, which is now travel. Sorry, that's confusing. And then we're going to move to the next flush queue and render the changes. And so this is why the present time updated to 1 minute too slow, because we update the present time before we call the render function. So it's still getting the old destination time since it's accessing it off the DOM. But hang on, we made 2 separate changes to the DOM. So how come it only called the render function once? Shouldn't it have added a second one for the second $nextTick? If we go back to the Vueture function again, it has this part here where when you call the watcher, it adds the ID to a list if it doesn't already exist. And then anytime after that the Vueture gets triggered, it checks if it's already in the list. And if it is, it doesn't push a new render function. So this is the way that, like, if a component's watcher is triggered twice, we only need to call the render on it once when all of its microtasks are done running. That's why here we only have 1 render function. Let's look at an example where the render happens at the same time, but it's the right time. Okay, so the first thing that we do is we resolve our promise, and then we push a $nextTick into the flush queue and call it. That results in a change to the DOM, so we need to push the render function into the next flush queue, at which point the first flush queue is over, so we call the render function in the second flush queue, and that means that we can move into the .then, which is our first microtask queue. So in the microtask queue, we're going to push another $nextTick into the next flush queue, and then move into the flush queue and call it, which results in the change in the DOM, which pushes the render function, and then it renders. Make sense? And then finally, it re-renders, and we're done. Except, if you remember, this clock only rendered once, but there's 2 render function calls. So what is happening here? We can see 2 render calls in the queue, right? So actually, I omitted a little bit of information when I said that nextTick updates the DOM, because it does update the DOM, but the DOM that it updates is the virtual DOM. So even though it looks like the page is being rendered here and here, it's actually only being rendered here. Notice also that if a new flush queue is opened from within an existing flush queue, even though it creates a distinct flush queue, they run back to back. So actually, the flush queue is more like a train or a subway than a bus, because even if you get on a different car, so long as you make it in time, you're going with all the other cars, right? It's not just going to detach. Okay, let's look at one more example. Here, I'm using set immediate, and I'm calling it SI in the visualization above. And side note, even though technically set immediate isn't guaranteed to always run before set timeouts, for some reason in the experiments I did with Vue, it seems like it does consistently always run before your set timeouts, which is weird because I looked at the package, and according to the package, it seems like if you're running it in Chrome, which I am, then it should default to set timeout 0, but anyway, just something to note. Okay, so this is the example where we had 2 separate renders. Where is the render happening? Well, okay, so the set immediate happens here, and then when that gets called, we finish the task. And that opens an opportunity for the microtask queue to slip in and start running, and that's where it renders. And then it also renders a second time at the end here. So what we can extrapolate from these experiments is that $nextTick and nextTick callbacks always run in the flush queue. The queue is flushed before the DOM updates, but not necessarily renders. And all $nextTicks nested at the same level will run top to bottom, meaning, for example, if I had 3 root level nextTicks, then they're all going to go into the same queue. So that means that you could potentially overwrite changes that you did before with newer changes if they're affecting the same data. Flush queues generated by flush queues run consecutively. In other words, they're blocking, so don't put time-consuming methods in your $nextTick calls. So if nextTick doesn't run after the DOM is rendered, why didn't the docs just say that, right? So let's look at it again. Defers the callback to be executed after the next DOM update. So it does totally say it. It's just like I understood it wrong, and it's been there the whole time. Like it says after the next DOM update, and I didn't realize that meant, oh, like after the next DOM update. So in other words, it runs after it updates, but not necessarily after it renders. And as we saw previously, just because you put something in nextTick doesn't mean that you have access to the newest data on the DOM, and it was right there the whole time. Yeah. So here's the thing. I don't know about you all, but I've had this realization at least 4 times, and that's like a very conservative number. So the first time was when I did this talk on view reactivity in 2017. The second time was when I was writing the lightning talk that inspired this talk last year. The third time was when I was writing this talk, and then again when I was writing this talk, and again, and again, and again, and again. And then there were countless times in between where I would encounter it either in the code or in the docs, and I just brush past it and be like, I'm not ready to deal with this yet, I'll worry about it later. And so that has left me stuck in some kind of endless hellhole where I'm like, I don't understand what nextTick is, and I keep on re-encountering it again, and again, and again, and again, and again, and again. And every time I re-encounter it, even if it's just like I took notes a minute ago and I'm looking at my old notes, I'm like, what was I thinking? I don't remember. I don't understand my old notes. I'm trying to like mind read my past self, but it's not working. There's some kind of block there. So why is learning a new concept so difficult, and why does it involve so much repetition of the same material and the same discoveries over and over and over again? I like to attribute this to a little thing that I call trash brain. So trash brain is like this. Imagine you've done something before, but then when you do it another time or another time, the context is just slightly different, so it feels familiar but not familiar enough that you realize like, aha, this is like deja vu, or I remember how I approached this situation last time. Another example might be you're on your way home and you take one wrong turn, and then somehow it's now super hard to find your way home, and it's extra frustrating because everything looks familiar, but it's really challenging for some weird reason. How come? Well, memories are formed and strengthened by repetitive experience and connecting as many neurons as possible to the memory, right? So my theory is that trash brain has too many of the wrong kinds of connections and not enough of the right kinds of connections. And here the wrong kinds of connections are remembering too much about the context, like remembering your memory as details of a story rather than remembering all the generic concepts that connect to them. So in other words, remembering it in your episodic rather than semantic memory. Now, trash brain can be great in some ways. It can help us suspend our disbelief, maintain a sense of curiosity, optimism when you're retrying something and you're like, maybe it'll work this time. But if it feels all too familiar to you in a terrible, terrible way, have no fear, because while I was working on this talk, I came up with a couple of different ways to try to help mitigate the effects of trash brain when you're learning new concepts. So the first one is limiting scope. Many of you, I hope, know the very satisfying feeling of when your PM gives you a new feature and you're like, not doing it, it's out of scope. And I find it really satisfying, not because I like saying, no, I don't want to build this new feature for the user, but because I have this schema that I can use to decide whether I'm going to build it or not, so I don't have to expend time and effort thinking about the decision and whether it's something that I need to decide right now. And so limiting scope when you're feeling out of your depth learning something new can help restore a sense of control and prevent you from expending time and energy on currently unnecessary decisions. Okay, also, forming a mental model of the bigger picture. I think part of the reason it's hard to retain new concepts is because you lack a framework to place them in. So even if you don't know the thing right now, you can probably imagine at least a basic container where it belongs. So for example, with nextTick, I imagined that it belonged in some magical spot in the event loop right before the render. And even though it turned out to be not exactly right, thinking about it in that way gave me some kind of foothold to build up on. But on the other hand, you probably are also very familiar with the pain of feeling like I've figured everything out and I've built a proof of concept to show it in action. And if my calculations are correct, this should work exactly. And then you run it, and you're so excited because you put so much time and energy into building something really cool, like, I don't know, a DeLorean. And then you run it, and everything crashes and burns, and you're like, oh no, this is terrible. So you need to remind yourself to stay flexible. Because although the mental model can be helpful to hang your concepts on, it's important to remind yourself that it's just a theory and it's not necessarily set in stone. And it's totally normal and totally okay to feel frustrated when your new discovery doesn't match the framework that you've created for yourself. But if at that point you don't take a step back to re-examine your mental model, then you could potentially create more pain for yourself in the future. And you don't want to let it become, what did Chris say, like a foot gun? Yeah, no foot guns. So for example, if you spent a lot of time in a coding example only to realize that it was an incorrect thing that just was confirmation bias, not that I know anything about that, that's why flexibility is important. So you also want to record your hypotheses and their results. As we covered earlier, coding is not orderly and it's really hard to keep track of how things run, but we can implement some sense of structure and process by forming and testing these hypotheses and, again, writing them down. Because even though it can be really frustrating to make the same discoveries over and over and over again, at least if you keep track of the circles and spirals that you've been running in, it's better than doing it blindly, and it can help you visualize the progress and growth and quantify the learning that you've been doing and reassure you that you're making progress. Finally, try to keep an eye on the bigger context, not in terms of code, but just like your life. Because it can be so frustrating to feel like you've started to get the hang of things and you just need that one more breakthrough and you reach for it and then you realize that instead of it actually being a breakthrough, it was more like a break everything you thought you understood about the thing you think you're learning and now you're in really big trouble. So for example, I could place a ruler on the ground and be like, oh, the earth is flat, and then present that theory to a room full of earthlings and also the people who built the planet. But even if you're in that totally hypothetical and not at all personal to my real life right now scenario, you probably won't fall off the edge of the world. And even if you did, you still learned something. Speaking of learning, let's review what nextTick is and is not and why you might want to use it. So it's a type of microtask. It gets bucketed with other nextTicks. It runs at a predictable-ish time. It's after the DOM update, but not necessarily after the DOM render. You take away one thing from this talk, hopefully it's that. And then it's like CSS in that it's super fun. I'm just kidding because CSS is way more fun, but it is like CSS in that you could potentially override your previous changes in the flush train, in the same flush train. So as my friend Kadil says, like the last one wins. Now that we've dived a little deeper, let's go back and look at this example again. So first we run $nextTick, which pushes all of these tasks into the flush queue and runs them. So yes, that means we are shoving our set immediate and set timeout into the flush queue. We're cheating a little bit. And then that pushes the next layer of nextTicks and runs them, and then our next layer of promises, microtasks. So we go through all the $nextTicked and microtasked callbacks, then run our set immediate callback, and the thing that it pushes into the flush queue, and then finally we call our set timeout callback. And that looks something like this. So if you're curious about how this breaks down into those different queues and where it renders, I'd like to encourage you all to try walking through this on your own. You have the tools now, and I promise after you've done it enough, it starts to become fun in its own special way. And if you're curious about trying this out for yourself, I've made this very rudimentary logger that visualizes, theoretically, the order of the flush and task queues, and there's a more thorough console log style system in there too. And I'll upload that at some point in the future at tessa.dev and maybe tweet about it. So this has been a really wild ride. Thank you for being such an enthusiastic and, oops, I went back and not to the future. Thank you so much for listening. Hopefully now you feel a little bit more comfortable with code syncopation than you did before. Thank you so much to all of the wonderful people who helped me with this talk. And thank you all for joining me on this journey. Back to the Vueture.